My name is Professor Stephen Wright. I am the Professor of Aviation and Aircraft Systems here at Tampere University, and I am here to support the university's offerings for aeronautical engineering, aircraft, and all other matters that involve aircraft or things that fly. I really like the city. It's got lots of nature. It's a great combination of an urban environment, so I don't have to go too far to the shops, but also it's small enough that within a few minutes I can then be out in the nature. I can enjoy walking in the forest, go for a swim in the lakes, providing it's warm enough, and it's really relaxing, and it's a lovely place to be and to live, and that's one of the reasons why I've relocated permanently to this area. The thing that really attracted me to Tampere, work-wise, was the broad capability that the university has. By that I mean that it covers so many disciplines within engineering, all the way from the core design, the aerospace type, the flow calculation capability, right to the other end of the spectrum, which is the new developments in materials, carbon fibres, composites, and you have the equipment and the capability. And this broad understanding and facilities is really important to somebody like me, because aviation is this multidisciplinary approach to it all. So that's the university side of why I came. One of the big important things is to support the research of the university. So one of the things that I'm interested in, well, there's lots of things I'm interested in, but my doctorate was on the fouling and failure of air conditioning systems on aircraft, commercial aircraft. So I'd be really excited to try and further my work in this discipline. One of the reasons being is that it's applied to a very popular European aircraft, and the problem hasn't been fully resolved as yet. So every now and again, air conditioning systems overheat and switch off, which poses a technical problem to the airlines, i.e. they have to make an unscheduled landing. So I'd like to sort that out and help them improve their performance in that respect. Coming from the commercial airlines originally, I know all the metrics that the airlines need to work on. So what does that mean? It means that they operate an aircraft, they want the thing to work in the first instance. They want to know when it's going to go wrong. That's really difficult because the equipment built on board typically is a test button. You push it, it's got two lights, a green and a red. Green means it's great, red means it's broken. Take it off, swap it for a fresh one from stores. But you don't get any information about the degradation of the system. So system reliability is really important. And I want to, again, help the airlines, help the universities to improve their capability, try and find that commercial link to support the industry, helping people get the right skills to get into work. I've had a great career, really exciting career all over the world in commercial aviation. That's only been possible through good education, and I'm really grateful. So I see my role as imparting some of that knowledge to new people. And the reason why I want to do that is I've really enjoyed working for the airlines, and I would hope lots of other people could have those sorts of experiences, airlines, manufacturers, working in the industry, because it's really exciting. Hopefully that gives you a little taste of some of the things that interest me, research-wise at the university. Now, the AirHow project is particularly unusual and very interesting. And why that is the case is the AirHow focuses on taking Finland's know-how, what we do really well over here in commercial aviation and the wider industry, and attempts to share some of that knowledge with other countries, organisations outside of Finland for the benefit of the industry. Can I give you an example? So within engineering, you have individuals that have to be licensed when they conduct maintenance activities. It's called an EASA 66 license. So you get two flavours. The main two flavours that we're interested in are something called B1.1, which is heavy fixed-wing aircraft, and B2, which is for the same aircraft, but instead of it being the dirty stuff, which is B1.1, i.e. fixing the airframe, fixing the engines, a little bit of tinkering with the electrics, B2 is focused exclusively on electrical avionic. So it's the clean stuff, the computers, the boxes. So we have these two traditional disciplines. Now, normally in most of Europe, you've got the dirty engineers and the clean engineers. These very two distinct qualifications. But here in the Nordic region, and also especially in Finland, you have the capability, individuals qualifying on one license, let's say B2, and then going on getting further education and then experience with the employer and becoming both B1.1 and B2 license holders. Now, this is unheard of in most of Europe. And what it means is that an engineer working at an airport can be really, really useful to an airline. Why? Because you can go up to an aircraft, doesn't matter what problem it's got, what fault, if you're licensed on that type, then you can fix pretty much everything. And that is really important to an airline. And it's this know-how, taking this local corporate knowledge that we have here in Finland and being able to share it and apply it with new partnerships. So we're not looking to take over the world, quite the opposite. But we are looking to make strategic alliances to then have this symbiotic relationship with other countries to deliver this knowledge hand in hand with what we can do locally. So at the moment with AirHow, it's formed with all of the organisations that have an input into aviation. So at the top end of the scale, we have Patria, and that's a large organisation. They do a lot of military maintenance and delivery. They also have the latest approved pilot flight crew training centre here in Tampere. Also next door at the airport, we have Tredu, which is the government-sponsored training school, and they can do maintenance training for both B1.1 and B2 licensed aircraft engineers. The list goes on. Then we have the Airport Authority for the whole of Finland, also dealing with the local organisations. We have more or less every input, every organisation that has a input into aviation. So another company that comes to mind is Insta, a really strong local company, and they specialise in electronics, digital communications, satellite communications. They support the whole of Finland in a lot of strategic military and government communications. But in the case of aviation, they also deal with aircraft communication systems in both military and civil aircraft. Looking further on, we have the capability of developing and designing airports. So we have lots of smaller organisations that support the local infrastructure, developing that. Why is that important? Because we have a local international airport, and this has been particularly successful. So our local airport at Tampere is particularly interesting because it's a shared facility between a number of major players. So we have lots of international flights coming and going. We also have NGO capability, i.e. with the Red Cross, and the local facility to store the disaster relief equipment that may be required worldwide. And lastly, the use is also with the Finnish Air Force and the Defence Forces for that side of it. People don't just make airports capable of carrying and bringing things in. This has to be carefully thought about, and that's one of the huge critical advantages that our region has, that the regional development, the local government, Business Tampere, has had the foresight to recognise this capability, to then have the will and the want to invest locally in our airfield. Great example. We want to have lots of low-cost travel, and we have that. So we have low-cost airlines coming in, and also regular scheduled airlines, and they operate lots of flights out of the airport, and this is really good. The airport's manned, it has an air traffic centre, so we can handle the flights coming in and out. But this is just one side of the business. The next interesting thing is, for high value goods, really high value goods, so we're talking about things like mobile phones, laptops, you don't necessarily want to ship these in via a sea container all the way from the country where it was manufactured to locally. Actually, the way that it works is that high value freight is put on an aircraft. Now, why this is a particular problem is freight is really important to the state, the goods of your country. And if your airport happens to be really popular with lots and lots of flights, for instance, at Helsinki Airport, at Vantaa, it's really busy. So you have a slight problem, and now all of a sudden, your passenger aircrafts are slowing down because you can't land them as quickly as possible. Now you put freight into the equation because everybody wants the latest phone, because you're flying them in. Now you have a bigger problem because the delays have become much more pronounced. So therefore, what we need to have is a capability of saying, well, do we really need to fly all the freight into the main passenger airport down at Helsinki? And I would say to you, maybe not. Maybe what we need is to have more of a transport hub for cargo and services coming in locally, because Tampere is located strategically in the right part of the country, and it's got great rail and road networks, and therefore you could fly all these high-value goods in from around the world, not necessarily from just Finland, and then you can disseminate it across the country. And that's why the airport is in this perfect strategic location. And locally, they've made the infrastructure. So this is one of the reasons why we are in a really great location. The relevance of the airport is it's really critical for the local economy. It enables people from far away to come to the city with not much trouble. So without this local airport, it would be really difficult to attract high-level business. Having a local airport means that you can fly people in for those really high-level important meetings that's necessary for things like investment, making new jobs in the area, expanding the local economy. So what makes Pirkla Airport really important here is the fact that it's been invested heavily in by the local government and supported regionally. This is really unique in my professional opinion, that you have a commercial airport. This particular location again is really unique for the region, because the region has recognised that we need to have a skilled workforce that can go to work to support all types of the business here. And this is interesting because normally a training organisation wouldn't be anywhere really close to an airport because it's just too expensive. And yet, what the regional government has done is they've provided this magnificent facility here, and we can see some examples of live aircraft around us. This gives the young people here a chance to work on real planes, not to look at textbooks, but to do things properly. The local facilities here, the local college, Tredu, they have government approvals to conduct maintenance training. This is really exciting because it means that they come here, they get high quality education, the Finnish way, and then they can graduate with the European approvals necessary to then go on and get a job with a bigger company. So this is just Tredu. Next door in Patria, this is a really positive venture because we have an approved flight training organisation. So an individual wants to become a pilot, they can come here to this building. They can then undertake ground school classes, take the exams, get approved exam passes, and then go flying here. So this facility is really underpinning this skills requirement that has been identified. So youngsters, young people wanting to get into the industry, this is a really great place to come and live, study, and then continue their careers in this region. And that's why it's so special. The future of flying here is really exciting because we have so many new things going on. So we have the Air Arhau project that brings all this commercial know-how together, and we're then spinning it out to the rest of the world, giving them a chance to learn from our capabilities. That's one side of it. Another side is this future that we have. So what we mean by this is we've identified the skills gaps, namely for flight crew, for engineers, and for other disciplines. And working closely with the university, with people like myself, we've been able to then offer new opportunities for people to gain things like degrees that are bespoke to their chosen career, to then help them. Looking further into this, then we have new technologies coming forward. So one of the interesting things is that within Europe, we have a vision called Flight Path 2050. And this is how we, as a European group of countries, need to change aviation to do things really exciting in the future. Education is one of these critical areas. And we're already addressing that because we are the principal lead at Tampere in both aviation and aeronautical engineering. That's what we already do. We're offering this opportunity. And then we have the further advances using technologies. Could Tampere be the next capital? It is already the heart of aviation. I think that there would be a significant misunderstanding if people thought the national airport at Helsinki, Vantaa, was the focus, the sole focus of aviation. I don't think it is. And the reason why I say that is Vantaa is very popular for large aircraft coming in or out, but the actual training and the education and all the other support areas, the areas for growth, are happening here, right now. This is the place to be. And this has only been possible by the support and the foresight by organisations like Business Tampere, the Tampere Regional Council, the Airport Authority, and the local economy supporting this operation. So this future of aviation in Tampere has been handled really well. The foresight to actually improve matters is really positive, and identifying a single point of contact to lead this forward transformation, in my mind, is fantastic. I know from my own workings that the university and the region has had really close cooperation, and I see myself as supporting this opportunity to make things better for both Finland and also for the region. It's really positive, and it will only enhance the commercial aviation and all operational aspects of aircraft engineering, aviation and aerospace for this particular area. I think for the rest of the world, what they need to say to themselves is, if one little company tries to do everything by themselves, it's not going to happen. For instance, typically an organisation would be, let's say, a flight training provider. They will teach people how to fly planes, and they will specialise, and they will do this very, very well. But then you don't find that same know-how with engineering. Engineering training is completely different to teaching people to fly. Fixing planes is complicated. Teaching people to fly is a different skill altogether, and this crossover is not natural. Then we're talking about the infrastructure, how to improve the airport, how to put in the high quality and the necessary technical developments to then land large commercial aircraft. Well, a maintenance training school is not going to have that skill because they're focused on fixing planes. So this live project that is being demonstrated by Air How, this is really the future. This stands Finland out against everywhere else, in my opinion, because it shows our capability to work together symbiotically to then achieve an objective. And this is well outside of the scope of one organisation, but for the benefit of all organisations in the region. One person wins, we all win. Well, the future of flying is really being addressed by the European Commission, and they've published a report quite recently called Flight Path 2050. And these are the headline objectives between now to 2050 to make things better. So one of the areas that they talk about is ensuring that people can travel, the mobility of European people, and that's clearly defined. Another area is having the right people with the right skills. And I think as a university, we're working hard to address that, which is good. But one really exciting area that they're working hard on is the reduction in things like carbon dioxide, nitrous oxide emissions, particulates, which are the small bits, and lastly, in the reduction in noise. So the Commission wants aviation, because we've got this 5% expansion year on year. We want to then make sure that we don't adversely affect the climate from operating commercial planes. So this is an A320. This is a live aircraft. We're at Helsinki Airport at the moment. And we want to make sure that the reduction of carbon dioxide is 75% of the level that would have been produced when this aircraft was produced around the 2000 year mark. So that's the big goal that we're aiming for. It's these big reductions. And the only way you can do that is to have people like the European Union heavily invest in future technologies that will change aircraft like this, that will fly potentially way beyond 2050, but they will need to have new technologies added to them in addition to new planes that are manufactured to make sure that they meet these future goals. That's the big goal. That's the future foresight. And as part of AirHow, we're looking to address these big headline values. So aviation's always been very sensitive about greenhouse emissions and so on. So what they've done is thought about this, and they're actively seeking new means, new measures to try and stop the emission of gases. And at the moment, it's really difficult because a large plane like this A320, legally, you can only fly it on one fuel. It's called edit1, and it's kerosene based, and it's a blend of carbon 12 to carbon 20. And you buy it, you put it in, you burn it, it makes carbon dioxide, water, bit of noise and some other bits and pieces. You're not legally allowed to put anything else in. If you swap the fuel out for some form of biofuel, that gives us problems. So what we're trying to do is come up with new means to either change the way that we operate the aircraft, maybe change the fuel. There's a lot of work going into that at the moment. The ultimate one that they're looking at for around 2030 will be we take off the kerosene burning engines and modify the fuel tanks and replace that with electric motors and batteries. But you can imagine that that sort of retrofit is going to be very complicated, and it requires a whole load of new things to be developed and delivered. Aviation will have its place, but it's all about this slow incremental change to ensure safe and reliable operation of large commercial aircraft. Definitely, the way that technology will change is really unusual. So we will foresee things happening that will transform the way that everything operates really quickly. Great example is drones. At the moment, we're behind the loop on legislating using drones. They've been available commercially for the best part of 10 years. And it's only now, right now, that businesses are getting permission, like in America, to operate as many drones as they want, delivering as many packages as they want. And this just happened very recently for a large American delivery company. So the next big disruptive technology for drones will be probably the carriage of people in them. And it won't be to go far. It will probably be for a 15-minute, a 20-minute flight. And realistically, it will probably be for one person. But once we start applying these new technologies, flying in airspace, it's going to change everything. But one of the big challenges is, what about the other planes, like this one? So we're going to have new rules and new thinking on how we're going to implement this new technology into society, because flying drones, flying cars, and large aircraft flying at 600 knots don't mix particularly well. And we're going to have to think about the technologies that we're going to use to keep everything separated. And to do that, then we'll have a safe operation. The only thing to say about Flightpath 2050 is it's one of the most exciting, forward-thinking concepts for commercial aviation, in fact all flavours of aviation. It really will change things because we are making the incremental investments right now to bring these new technologies, and it will then change the way that we travel for the better, making it cheaper, faster, more reliable, and allowing people to move more freely, not just within Europe, but ultimately around the world. For me, what really excites me is the freedoms that it gives you. Going flying, there's nothing more satisfying than getting in an aircraft, maybe not quite as nice an aircraft as this one, maybe something somewhat smaller like a little aircraft Cessna, taking off, going down the runway, and then having the freedom to ask to go somewhere and landing. That's really beautiful for me. I love the changes in technology, find it really exciting, and I'm really passionate about the whole industry. It's the most exciting business I've ever worked for, and I feel so privileged to be in a position where I can positively influence my own future and also the future of many other people, and to support Finland in this activity. So this is a Cessna 150 aircraft. Treadu's done something really unusual. What they've done is taken this classic aircraft, probably 1960s, and you can see that it has the original analog instruments. Normally there would be a big six, we call it, which tell you how the aircraft is flying. So typically you've got attitude indicator, there'd be something called a turn coordinator, altimeter, this is a directional indicator, an airspeed indicator, and possibly one or two other instruments. What they've done is they've retrofitted, they've moved these 6 instruments, and we can see that they've got some analog components here. And then they've retrofitted this with the latest technology. So this is a Garmin system. So when you fly large commercial aircraft, you don't usually fly with these sorts of old 1960s technologies. Life moved on. Think about your hand phone, how it changed. They now fly with these electronic displays. So this replicates everything. Map, how the aircraft is performing, and it also will interface with your radio stack in the center here. And this will tell the pilot where he is, or she, which direction they're flying, are they climbing, descending, which frequency are they talking to air traffic control. It will also tell them the direction that they should be flying. And Treadu, this training organisation, has been very successful in retrofitting this aircraft to this technology, and it works. It really works, and they can calibrate it and fly an aircraft like this using this technology. This retrofit process is really state of the art, and they're demonstrating this to the real young people that are moving into this industry, which is really exciting. Hi, I'm Professor Stephen Wright. I'm from Tampere University. This is a Falcon aircraft, and it's used by Treadu for approved maintenance training for their Part 147 approval process.